so section 12.5, this is our last section on just volume. Okay, the next section we do is going to be about spheres, but we're going to look at surface area and volume in the same day. All right, and we haven't done anything with spheres yet. Okay, so after today, you'll know how to do everything with prisms, cylinders, cones, and pyramids. All right, so this is the formula that we learned in the last section. Okay, the volume of the prism is the area of the base times the height. Okay, so sometimes what I do if I can remember to get all the stuff, I don't have it today, is I show basically a pyramid and a cube that have the exact same size base, okay, and have the exact same size height. Okay, same size base, same height. And I basically say, if I were to take this pyramid, turn it upside down so the point was down, and started filling it up with water, and then dumped it out into this cube, how many of these pyramids do you think I'd have to dump out to fill up the cube? Anyone have any guess? It's a pretty nice answer. 2. 2? All right, so maybe you fill up the pyramid twice, dump it into the cube. It's not 2.
1.5.
No, it's a little more than what Luke said. 3. It's 3 times. If you filled up the pyramid 3 times, dump it into the cube, it would fill it up exactly. That assumes these 2 objects are the same height and they have the same size base. Right? And I think that's what I wrote basically right here. Actually, I didn't get specific. All I said here is that the pyramid would have to have a smaller volume than the cube because the sides taper in versus a cube, they stay straight. Okay? But it turns out to be exactly 3. Another way you can do it if you don't want to do it with water, we've done it with sand. You can do it with sand or little plastic beads. Okay, you can fill it up. And since it's 3, this is where the 1/3 comes in. All right. So if you found the area of the cube, it's 3 times as large as the prism. Or you could say, pyramid. Or you could say the pyramid is 1/3 the volume of the cube. So here's your formula for the volume of a pyramid. In fact, this formula will also work for the volume of a cone. 1/3 the area of the base times the height. The only difference with a cone is I can be a little bit more specific than this. All right, now why can't I be more specific with B when I'm talking about a pyramid? Why can't I just say what the shape of the base always is? Yeah. Yeah, it could be any polygon. You could have a pyramid that's a triangular base. You could have a square base. I think that was like the one on the other page. You could have a hexagon-based pyramid. Okay, so I can't tell you what the area of the base is. It could be different for every pyramid.
Giza square base. Square base.
A square base? This is a pyramid with a square base.
That's the ones at Giza.
Yeah, I think this is the one most people think of. When you think of a pyramid, they think of like a square base, 4 sides. Yeah.
Hager,
Yep.
can you talk about the MCAS now?
About the MCAS?
Yeah.
No, not yet.
Are you serious?
Yeah, I can't do it.
Really?
Yeah.
Oh, okay.
Sorry.
I thought you were just joking with me.
So, on the volume of a cone, okay, I've got 1/3 the area of the base times the height, but I can be a little bit more specific about what the shape of the base is. In a cone, the base is always what shape? Circle. And the area of a circle is pi r squared. So all I'm going to do is fill in pi r squared for that. And there's my volume of a cone. And it will always be pi r squared because the shape of the base in a cone never changes. Okay, the letters stand for exactly the same things they did before. B is area of the base. H is height. R is radius. Okay, R is radius. Okay, keep in mind, especially with the pyramids, if you've got a shape that we don't know the formula for, we have to look it up. Okay. Squares you should be able to do. Rectangles, you should be able to do those. Hexagons, you got that one. Equilateral triangles, you also have that one. So if the shape was an octagon, we don't know that one. Okay, we'd have to look it up. One thing you could kind of use as an approximation, although this doesn't work extremely well. What happens is you keep adding more and more and more sides to a polygon. It gets closer and closer to what kind of shape?
Circle.
It gets closer and closer to a circle. Okay, eventually if you add, here's a shape with 16 sides. That's 16 sides. Well, maybe I can't show you. Let's try again. I can do 12. It gets my point across. So the idea is, as you get closer, if you have more and more shapes, it gets closer and closer to a circle. Okay, so here's a pyramid. This time it's a, well actually you tell me, what kind of base is that? Hexagon, and because all the sides are marked with those marks, what word do we use to describe it? Regular. Yep. Because this is also hexagon. Anything that has 6 sides. Okay, it's a concave hexagon. Good to know for the final. It's a hexagon, but this time all the sides are congruent, all the angles are congruent. It's a regular hexagon. Okay, and the question is, find the volume of the pyramid. Okay, so use your formula. Okay, volume equals area of the base times the height, and we got to put a fraction. What's the fraction you put in front? You put in the 1/3. Okay, so just remember, if you're dealing with the shapes that come to a point, cones and pyramids, throw the 1/3 in front. If you're dealing with shapes that are like cylinders and cubes, it's the same formula without the 1/3. Okay. All right. Here's where we're going to need our formula for the area of a hexagon. So it's 3s squared, square root of 3 over 2. So 3. The first 3, I want to make sure everyone understands this is coming from the formula. Now the length of the side is also 3. So I'm going to have another 3. So times the length of the side squared times the square root of 3. And then divide by 2. Okay, if you want to save a little calculation, since you're multiplying these 4 things together, if you multiply 3 times 1/3, you get 1. Okay, you can cancel those. And now we have 9 square root of 3 over 2. Okay, now if they didn't want that rounded, we could just leave the answer like that. Okay, in your book, I'm trying to see if they rounded it off. Yeah, I think they're going to round it off. Okay, any questions on what we did there? Oh, one more thing I forgot. What did I forget? I've got 1/3, the area of the base. What's one more number I should have on the end? The height. Yeah. Sorry about that. So make sure you put times the height on the end. Okay, everything here is still fine. Just put on the times 4. Okay, 9 times 4 gives me, how much is 9 times 4? 36. Square root of 3 over 2. Now I can divide 2 into 36. Jacob, what's 36 divided by 2? 18. Yep, 18. So there's your final answer. 18 square root of 3. What was our units? Centimeters? So how should I write my label? Because it's volume. Connor?
Centimeters cubed.
Good, centimeters cubed. Remember, volume is 3D, area is 2D. So you either put the 3 or the 2. Okay, any question on that? Okay, does everybody know if I wanted a decimal, how to type this in? How to round off the square root of 3, hit times 18 on your calculator?
I don't know.
You sure? So if I wanted a decimal, you just type in 18 times the square root of 3. It's about 31.18. Okay. Yeah, that'd be centimeters cubed. Yep, centimeters cubed. Okay, let's see. Do we have another? Okay, let's try the cone. Start out with the same formula. 1/3 area of the base times the height. Except because of the shape of the base is always a circle. Kira, what's my formula for the area of a circle? Fill in R, fill in H, do it out, and you're done. Because this has decimals, the answer is going to come out kind of messy. Right? So just make sure you use your calculator. Doesn't say where to round on this problem, so I'm just going to go with 2. Okay, now on MCAS, they usually have you round pi to 3.14. I'm not going to do that. I'm just going to press the pi button. So when I need pi, I'm just going to use the pi button. What do you think's better? Rounding to 3.14 or use the pi button?
Part of pi button.
Why?
Because it knows more pi than 3.14.
Yeah, calculator knows more pi. And it's a little more accurate. Depending on what you're doing, maybe you need that accuracy, maybe you don't. If you're machining parts, you might have to go to like the nearest 10,000th. Okay, you have to be pretty accurate.
Oh, yeah.
All right, so we got 1/3 pi r squared times the height. Okay, so we're going to do all this out, but I want to know the first thing to do. Alyssa, what do I do first?
You 12.4 squared.
Squared, yeah. Always do your exponents first. Okay, so that's 12.4 squared, 153.76. Okay, I'm putting everything in parentheses here because I have decimal points. If I use the dot for multiplication, I think it's going to look confusing. You're going to have a lot of dots. Let me move it over a little bit. Okay, so we got our volume. I'm going to take 153.76, okay, multiplied by 17.7. I'm not even going to write it down. At the same time, I'm just going to hit divide by 3. That's like multiplying by 1/3. And I get 907.18. Times pi. Okay. If they ask you to leave it in terms of pi, you can stop right there. 907.18 pi. If they want it rounded off, just hit times pi. Okay, so 2,850.00. Okay, so this is the time when you round it. You're going to put 0.00 because it shows accuracy. If you don't put the 0.00, that means you don't know what comes after the decimal. We do. We know we have 2 zeros after it. In chemistry, I'm sure you do that kind of stuff with sig figs or stuff like that. So there's our volume. Okay, so now just put your units, cubic millimeters. That's it. Any questions on that? What's an oblique cone? We've talked about oblique shapes before. Versus the one I just did was a right cone. Yep.
And then offsetting.
Yeah, the tip of the cone isn't centered over the base. Okay, so there's an oblique cone. Okay, turns out doesn't matter if it's oblique. Same formula. 1/3 area of the base times the height. Okay, so just fill it in. 1/3 pi. This time my radius is 1.5. What would you do if they drew the line all the way across and said that was 1.5? Could you just plug it in that way still?
Yeah.
Well, yeah, what would you have to do? Someone said. Yeah, if they drew the line all the way across, that means they're giving you the diameter. Make sure you take half of it. A lot of people make that mistake. If you don't take half of it, it comes out wrong. Okay, so let me show you how you can type it all in basically one step. Okay, start with your exponent. Okay, that's done. Hit times 4. Okay, divide it by 3. And then hit times pi. Okay, so we get 9.42 cubic inches. Okay, now everything that we do with volume, we use cubic inches, but keep in mind there's a lot of ways to measure volume without these kind of units. Okay, I think last time people mentioned it, like gallons, liters, okay, quarts. Okay, that's all measurements of volume, but they don't use cubic inches. Okay. We generally don't use those measurements in here. Okay. Any questions on that? All right. Okay, how would you set this one up? What do you think the first thing you'd want to write down is? Maybe just looking at the picture, forgetting about the actual numbers. What would you want to write down first? Yeah.
The volume.
Volume of what shape?
It just says volume. It does the right cone.
Yeah, for a cone. All right. So they're telling me something about volume. They're drawing a shape of a cone. Might be a good idea to write down the formula for the volume of a cone. Okay, so volume is 1/3 area of the base times the height. Now, if you notice, there's always 3 variables, R, H, and V. You're always going to be given 2 out of 3. This time, they're giving you V and H, and they're having you solve for R. Okay, so take volume, plug it in. Okay, take your height, and plug it in, and solve it. What are we going to have to do to get R by itself eventually? Eventually, we're going to have to take a square root. Okay? Sometimes people make a mistake there, but anytime you have an exponent, the only way you can get rid of that exponent is, well, you could raise to another power, but an easier way to think of it is just take a root. Square root, cube root, okay? Whatever you have to look at the exponent. So there's our volume. We've got 1/3 pi, okay, I don't know my radius, times my height. Okay, now you've got 3 numbers you need to move to the other side. You can move them one at a time, and you can move them all at once. Somebody tell me, how could I get x by itself? What would be, doesn't matter if you do it one at a time or all at once. Just tell me at least something I could do. Let's try to get x by itself. Oh, Katrina? If we had a plus here, then we could subtract. That would be perfect. Okay, but we got to have a plus sign in there if we're going to subtract. So what operation would get rid of the 13 here? Yeah, divide. Okay, since we're multiplying everything on the right, we're going to use division to move everything to the left. Okay, and if that's all you want to do in that step, that's fine. Okay, we can just do one step at a time. Okay, take 2614, and we get divided out 201.08. Okay, how about that 1/3? How could you move that to the other side? There's 2 ways to do it. One way I think is a little easier than the other.
Multiply both sides by 2.
Yeah, why don't we just multiply both sides by 3. 3 times 1/3, that's gone. Okay, this time you don't even have to rewrite it. Just write it down like that. And now how about the pi? We can move that just like we moved the 13. So James, how would I move that?
You divide it.
Yep, divide by pi. It's gone. And now when you do out what's on the left-hand side, you're going to have x. Okay, Wait a minute, don't forget, that was a little bit of a mistake, but nothing we didn't catch. Make sure you put the exponent of 2 on your radius. Okay, if you forget that, it does come out wrong. All right, so we got 3 times 201.08. Now, at this point, we've already rounded this off, okay, 201.08. It's kind of weird to use something that's exact and then use something else that's rounded off. It's still not as exact as it could have been. I'm just going to hit divide by pi rather than start rounding things off even worse. But okay, so it's about, this isn't extremely accurate, but it's about 192. Okay, 0.02. And now your last step, take your square root. And we get about 13.86. Okay, about. Now, is 13.86, let me scroll back up, that's x. Is x the volume?
No,
No, what is x here?
the radius.
Yeah, it's just the radius. Okay, so all you're going to put is a label of feet. Don't put feet cubed on that. Okay, any questions on how we plugged those numbers in and solved it? Okay, not too bad. Once you know your formula, just pretty much basic algebra 1. All right, so next thing we're going to do, we're going to find the volume of a composite solid. Composite solids when you take 2 shapes and put them together. Okay, this is the example I was telling you about that you can see on ships. Okay, it's called a nautical prism. Okay, anyone ever seen a nautical prism before? Or know how they're used? Yeah, can you explain to me how it works?
Maybe tell direction.
I think maybe you're thinking of like a compass or something. This is pretty much just like a block of glass. It doesn't tell direction. It's basically, or it could be crystal, but it's shaped a certain way. But this doesn't tell direction. Yeah.
Isn't it shaped to reflect light in a certain way?
Yeah, it's shaped to reflect light in a certain way. Okay, this is what a nautical prism looks like. Generally, they have like a hexagon as a base, and they put a pyramid on top of it, hexagonal pyramid. Any thought how you could use that on a ship to give you light below deck? How though? Like you just put it on the table, it's just going to like light up for you? Battery operated?
Upside down, and it's going to be on the ceiling.
Yeah. Okay, what they do is, if you were looking at it from the deck, it would look just like this. Okay, it's nice and flat. So they take it, they flip it over, they put it upside down. Okay, and because the base is a little bit wider, if you can see it better here, the base is a little bit wider, it won't fall through. Okay, so they cut it just right, put it upside down, and that's pretty much what it looks like in the ceiling. So it'll spread the light out in that room. As the light hits this part on the deck, it'll reflect down below. So if it's, even if it's a cloudy day, it'll still get a good amount of light below deck. Let's see if they got any other pictures. Yeah, they look pretty much the same. Yeah, but it almost looks like you have a little light right in the ceiling. And if you go to Mystic, Connecticut, has anyone ever been there? They have a neat aquarium there. Really, really neat aquarium. The Charles W. Morgan, it's pretty close to the aquarium. It's in the Mystic seaport. Sometimes the ship is there and you can actually go and tour it and check it out. Yeah. So if you ever have a chance to go down there, you look like a fun thing to do over the summer. Spend half the day at the aquarium and then go over to this area and check out the ship and stuff. It's a fun day. All right, so what they want us to do here is find the volume of this prism. Okay, what we're going to have to do is break it down, okay, into different parts. They've labeled everything for us. So the height of the pyramid part is 3 inches. The height of the base is 1.5. The side of each side of the hexagon base is 3 1/4, and then the side of each hexagon base in the pyramid is 3. Okay, so the top shape is a hexagonal pyramid. What's the bottom shape? Kind of the base that it's sitting on. What would we call that shape? Okay, so hexagon, it would be a hexagon if it was perfectly flat. But it's hexagonal prism, right? So those are our two shapes. To find the total volume, you're going to take the volume of the hexagonal prism plus the volume of the hexagonal pyramid. Okay, we're going to have to add those two things together. So pyramid, that's what we're doing in this section. Prism, that goes back to the other section. Okay, volume of a prism. V equals area of the base times the height. You do not put a 1/3 in front of that. Not for a prism. For a pyramid, you do. Now, just remember when we plug in, are these heights the same? The height of the prism and the height of the pyramid? Yeah? No. Okay, so when we plug in, we got to look at this. We have different heights to look at. We also have different side lengths on the bases too. Okay, let's start with the prism. Okay, area of the base. Use your formula for the area of a hexagon. So it's 3. The length of each side of the hexagon on the base is 3 1/4. So that's 3s squared times the square root of 3. Divide by 2. That's the area of the base. And then the height of the base, 1.5. So you know what? I'll just put times 1.5 in the top. Okay. That's what I'll do. You know what? Circle it in blue so you can see which one's which. That's the hexagonal prism. It's 3s squared, square root of 3 over 2, then times the height. Okay. And no, let's put it below. Plus. Now I need the volume of the hexagonal pyramid. Okay. For that one, I'm going to put in the 1/3. Okay. Area of the base. Just be careful this time. It's only 3 for each side, not 3 1/4. The reason they make it a little shorter is so that way when you put it in the deck, it doesn't fall through. Okay, you can, if you made it the same, if you cut the hole in the deck 3 1/4 inches on each side, you just put the prism in and fall right through. All right, so 1/3. Now area of the base, 3 s squared. Okay, s is also 3 in this case. Square root of 3 over 2. Okay, if we look back in our notes, I think we already found this, but actually I think we did it with a height of 4, not 3. Okay. So that's 1/3 area of the base times the height. Okay, that's the volume of the hexagonal pyramid. Okay, there's nothing really that hard about this problem. You're just doing one shape, you're doing another shape, you're adding the two together. Okay, and we just have to do all that out. Okay, any questions on how you do all that out? If not, then I'll just tell you what it comes out to. Okay. It comes out to about 64.54. Okay, 64.54 cubic inches. Okay, if you find the volume of the pyramid, okay, that part comes out to 23.38. That's just the top part. And then the bottom part is about 41.5. 41.46. 41.46. Which, to me, looking at that, it almost seems kind of funny. I would have thought the pyramid on top would have more volume than the base. The base doesn't look that big to me. But that's what the book says. The volume of the base is 41.46, the prism. But I guess you also have to think the sides here, they're tapering in, so it's getting smaller as it goes towards the top. Right, any questions on that? Okay, so that's called a composite solid. Two shapes, stick them together. Two other shapes you might see a lot together are cones and cylinders. You can easily stack a cone on top of a cylinder, and the bases line up very nice. All right, so this will be our last one. We'll stop with this one. Okay, take a second and just read through this. Okay, it says oil is being poured into a funnel at a rate of 147 milliliters a second. Okay, and it flows out of the funnel at 42 milliliters per second. Okay, because of the width at the bottom, it can only flow out so fast. It says estimate the time it will take for the funnel to overflow. So in other words, if you just keep pouring at this rate, okay, as you're pouring, it's going to keep emptying, but it's not emptying out as fast as you're pouring it in. I want to know how long is it going to take before the funnel fills up and then overflows.
You have to do some conversions.
Yeah, there's a few ways to think about it. Some people might have a more mechanical kind of mind and be able to figure it out in different ways. Does anybody have any thoughts? How you could figure out how long it's going to take. Now, the shape of the funnel here, it does straighten out a little bit, but you can kind of ignore that. You can almost pretend like it's a cone shape.
You have to find the volume of the cone first.
Okay, let's find the volume of that cone shape. Even though it doesn't come perfectly to a point, let's estimate it. So this will tell you how much oil would fit whatever we're pouring. Yeah, oil in the cone. 1/3 area of the base times the height. Okay, let's fill that in. Okay, this time my radius is 5. My height is close enough to 8. Okay, we'll go with 8. Might be like 8.5, but that's fine. Okay, so 5 squared is 25. 25 times 8, that's 200. Just think of like having 8 quarters. It's $2. Now I'll take 200 times pi and then divide by 3. Okay, so the volume of the cone is 209.44 cubic centimeters. Okay, so that's good to know, but it doesn't really answer the question. How long will it take the funnel to overflow? Okay, so what do I do now?
You gotta subtract 42 milliliters from 147.
Good. Why would you do that?
Because that's the actual amount like that you poured in. Like, 'cause if 42 is lost every second you pour in 147, then you might as well be pouring in 105.
Right. So basically, like what Luke is saying, if you put a stopper in the bottom of the funnel, okay, and you poured in 105 milliliters per second, the exact same thing would happen if you just took the stopper out and poured in 147. Okay? So really, this cone is filling up at 105 milliliters per second. Denver?
Can we convert that?
All right, so Denver's mentioning something about a conversion. What did we say it was? Well, let me write this down first, 105. Okay, conversion. Why would we do a conversion? yeah, let's take a look at that and see what the conversion is between cubic centimeters and milliliters. Okay, let me pause for a second and show you that. All right, so as we just saw, if you convert, it's a 1-to-1, okay, 1-to-1 ratio from cubic centimeters to milliliters. Okay, not all conversions are that nice. Some of them are a little more complex. All right. So now what would I do? I've got the volume that the cone can hold, and I've got how fast the liquid is basically filling up. What would I do next? Yeah?
You take the volume and divide it by the rate of how fast it's filling up.
Yeah. Take your volume, 209.44, and divide it by 105. Okay? Basically, we're figuring out how many times does 105 go into 209. Okay? And that's going to tell us in seconds how quickly it's going to overflow. Okay, so based on our numbers, I'd say it's just about 2 seconds. Just about 2 seconds. Okay, and that's what the book said, just about 2 seconds. All right, so if you're designing some kind of system, okay, maybe you're designing like a pump system for someone's basement because they get water in it. You probably want to design it so the pump can handle a lot more water than what's coming in. All right, so that way it can pump it out faster than it's coming in. Okay, if you don't put in a powerful enough pump, then what's going to happen is the pump is going to just keep running and running and running. It'll never keep up with the water that's coming in. So then at that point, maybe you convert it to like horsepower. I need a 1/2 horsepower motor, 3/4 horsepower, whatever it might be, to pump it as fast as you need to pump it. Okay, any questions on that one? Okay, so all kinds of applications to figuring out this kind of stuff for real life situations. All right, so the homework, it's not really like a string of problems, it's just a bunch of individual ones, except for 8 through 12, that's all. And then it's 14, 15, 17, 18, 20, 21, 23, 31, 35, and 36. Okay, so we'll go over that tomorrow. Actually, I'll see you guys. Yes, I will see you tomorrow. Okay, so we'll go over that tomorrow.